Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So I'm back with some more tricky circular measure questions. Let's look at the first question and it's a walkthrough solution. So what I'll do is that let me first copy this question. Let me paste it over here and then I'll show you the solution. Now over here the question says the diagram shows a metal plate and that's the name of the metal plate, which is A, B, C, D, E, F. So it's starting like this, A, B, C, D, E, F. That is the metal plate. So subtract this, that's the metal plate. It further says which has been made by removing two shaded regions. That's one shaded region, that's the other. Now right away you can judge that both shaded region, they are exactly the same. How do I know that? The parallel edges are of both length 12 centimeter. So this is 12, this is 12, the radius is 10, the radius is 10. So is this radius, so is this radius. First part for 2 marks. Show that the angle is 1.287 radians. Second part, perimeter of the metal plate. Third part, area of the metal plate. Now, first thing first, if I'm interested in this angle, I think the most obvious thing is using cosine rule. So first keep in mind, I'll be using cosine rule. Second thing, in order to find the perimeter of the shaded region, what I'll do is that I'll be calculating this angle, let me call it beta, and I'll be able to find this particular arc length. That will be the same thing as exactly this particular arc length. And once I am done with this, I'll add this 12, I'll add this 12, and that will be the perimeter. And now what about the area? From this sector, let me make it thicker. From this sector, all the way over here, let me find the area of the sector. Let me subtract the triangle and I'll find the segment. This segment will be the same, and then from the whole circle, subtract the two segments, you will find the area of the metal plate. So now the theory that I focus on, that is strategy before execution. Before you start the working, first develop the strategy. And that is a must for circular measure. Yes, it's a must for everything, but circular measure, it is a must. So now let's look at this question. Step number 1. Let DOE be denoted by theta. Applying cosine rule, as you can see, cosine rule is this much, correct to 4 significant figures. So step 1 is technically part 1. Step 2. That is the sector BODC. For this, find beta. These two angles lie on a straight line. They add up to 180 degrees. 180 degrees is called pi radians. So therefore, beta is this much. The arc length of this S is equals to R theta, provided theta is in radians, which is a must for circular measure. The angle should be in radians. The calculator should be in the radian mode. No compromise on this. So now we have BCD, that's the same thing as AFE, that is written twice. So I have written it once and multiply it by 2. Similarly, BA and DE, that is exactly the same. Add it all up. This is correct to 3 significant figure because that is the rubric. That is the set of instruction, the rules that is written at the beginning of the question. The third one, the area of the metal plate. Calculate the area of triangle DOE. This is DOE. That's the area of the triangle. Calculate the area of the sector. Subtract, you will find the area of the segment. So area of the segment is this much. Segment DE is the same thing as segment BA. Of course, you have to flip-flop the question many times. And then step 4, the final of everything. Area of metal plate is area of circle, that is pi r squared minus twice the area of the segment. You can either write 6.35 plus 16.35. My bad, I told it out, spoke it out. 6.35, that is 16.35. So subtract and then you get the answer. Don't forget 3 significant figures. That's how the first question is done and dusted. That's the mark scheme, if in case anyone is interested. The next part, again, let me copy this question, and this was one nice question. So now people remember this thing that you have to show all the working. There are some people, I'm sorry to say, but they are too much of a mental slave that they simply see this thing and they say, okay, this is the kind of working I need to do. People, remember, this is mark scheme. This is for the examiner. Yes, you should learn from it, but learn what? Learn this thing. Learn the final answer. These are the two options. This is one option. That's how you get the answer. Just check this. What I'm teaching over here with all the steps, that is a necessary, that is a must. So it is a must to show all necessary working, show all steps, no compromise, unless and until you don't want a nice grade. I don't know of anyone who is not willing to get a nice grade. If you want an A star in A2, if you want an A in AS level, then follow all the steps. Now over here, it says the diagram shows a rhombus. So now this is not a coordinate geometry question, but the rhombus property remains the same. The four sides are equal and the diagonals bisect each other at 90 degrees. Now it says this arc, I'll skip the reading for you. This arc is formed by this thing. And similarly, this arc is formed by this radius. Got the value? So now this is the center for this arc. And this is the center for this arc. They are identical arcs. The side of the rhombus is 5 centimeter, angle is 1.2 radians, the whole thing. Find the area of the shaded region, find the length of PQ at the end. Now what I've done is this thing. I'm first focusing on BAM. M is the midpoint where the diagonals meet. Now the diagonals are perpendicular to one another. I cannot get started unless and until I apply this property. Sine of 0.6, that is opposite, which is BM divided by 5. Hence you find the value of BM. Cosine of 0.6 is this adjacent, which is AM divided 5. And then you get this thing. So let me highlight this thing for you. So this is BM, that is over here. This is AM, that is over here. 4SF, 4SF. Now it says the first part, let me focus on just this much of the sector. So let me highlight this. Let me grab a thick marker and let me choose a green color. So now over here, this is what I'm focusing on. Hold for a second. Let me grab this thing. So now I'm focusing on this thing, the green marker. Just follow this. That is the sector that I'm focusing on. Now someone can ask this question, can we focus on this whole sector? Of course you can. What I've done is that I'm focusing on this sector. I'll subtract the triangle and I'll get the area of region 2. So now this 1 plus 3 is the same thing as 2 plus 4. All of these are exactly same areas. Keep that in mind. So let me find the area of the sector. Subtract from it the area of the triangle, I'll get area of region 2. I multiply it by 4, I'll get the area of shaded region. Let's look at the working. Area of ABQ, that's half into 5 square into 0.6. That is half r square theta. Area of triangle BAM, that is half into BM into AM. That is the height, that's the base. That's the height, that's the base. That's the working over here. Area of region 2, it's the difference between the sector and the triangle. Common sense, use it. It's the big one, it's the small one, subtract, you get this answer. All these 4 areas are the same, 4 times this, that is the answer and that is a perfect answer. Now part 2 was very nice. It's for 4 mark, but you have already done the working over here. Now we know that AQ, that is the radius. And AM is already calculated over here. That means the difference between the radius and this thing is MQ. MQ is the same thing as MP. Therefore, PQ is this plus this. That is it. AM is this much. AQ is this much. MQ is the difference. MQ and MP are the same. PQ is add these two. So therefore, this is the answer. Correct to 3 is F. That's how it's done and dusted. Now look at this mark scheme. It's not helpful at all. So it's not helpful at all because it's just giving you the answer. Only focus on the answer. And that also after you have tried out everything, tried out all working, all possibilities, follow the steps that I'm telling you and you're all set. Now, the last question for this particular video, and inshallah more videos will be coming up. You can also write in the comment section which kind of other questions that you want me to solve. So now over here, again, let me copy this and let me paste it over here. So you have a good idea. This was one nice, simple but elegant question. Now it says in the diagram, ABC is an equilateral triangle of side 2. So this is 2, this is 2, this is 2, this is 60, 60, 60. The midpoint of BC is Q. That means if I drop a perpendicular, this isosceles, technically it's an equilateral triangle, but we can also consider it as an isosceles. This bisector will divide this 2 into 1 and 1. An arc of a circle of center A touches BC at Q. And an R, find the total area of the shaded region. Now what I can do is that I can even do the working if you want. This is 1, this is 2. And I can also prove that this is pi by 6. Otherwise, I know that half of pi by 3 is pi by 6. For some people, I have even done the working. I have done the working for the Pythagoras theorem. AQ comes out to be root 3. I could have also used the concept of sine or cosine. Cosine of theta, which is cosine of pi by 6 is AQ divided by 2, hence you find the value of this thing. Now area of triangle BAQ, that is this thing. This is the base, that's 1. The height is root 3, that's root 3 over 2. That is the same thing as area of triangle AQC. So therefore the area of the big triangle, the equilateral triangle, is 2 times this. That comes out to be root 3. Someone can ask me this question. Can we do this? Area of triangle, that is half AB sine C. Of course you can. The 2 and the 2 cancels out. This 2 remains, root 3 over 2. That comes out to be root 3 centimeters square. Of course you can. Therefore, the area of the sector APR, that's half R square theta. Now keep in mind, R is not 2. R is this much. R is this much. R square theta, that comes out to be pi by 2. I have the area of the triangle. I have the area of the sector. This is simple working over here. And that is how we are done with 3 nice questions of circular measure. Stay tuned for more content on Mathematics with Shahab Yaqub.